Hi, I'm Costel. In this video I'll show you how I perform a procedure used to determine the absorption spectrum for an analyte. We know that all color compounds absorb certain wavelengths of ultraviolet and visible light and transmit other wavelengths. This pattern of light absorption of a range of wavelengths is called an absorption spectrum. Each molecule has a characteristic absorption spectrum that depends upon its structure. So let's start the procedure. First of all, let's gather the materials. So we have in here a spectrophotometer. It's a Genesys 20 made by Thermo Scientific. With a wavelength that is from 325 to 1100 nanometers, which means that this spectrophotometer is equipped with a halogen bulb able to deliver some UV light. It's what is called a UVA. Okay, we have the spectrophotometers. We have the cuvettes with I already prepared them. So I have in the first cuvette, which is the blank used for blanking as a reference. This one contains distilled water, about 2 milliliters, and the second cuvette has the particular sample, the analyte that we would like to get the absorption spectrum for this one. So this one is a total protein reagent. So today we are going to to determine plotting, of course, plot the absorption spectrum for this total protein reagent. How we'll start? We'll go, so first of all, we set up the wavelength at 400 nanometers. Let's do it in visible, in the visible range of the electromagnetic radiation. So we'll set up the wavelength at 400 nanometers. Okay, we'll start from there, 400 nanometers. Okay, one more. Okay, 400 nanometers. So we'll place the blank inside the cuvette holder in here. We'll do the blanking. So the blanking will set up I0. Remember the incident light intensity, right? So 0, and then we'll start measuring the absorbance. Absorbance at 400 nanometers. So it's about 0.027. So we'll change to 420 nanometers. Okay, we'll do the blanking first. Okay, with distilled water. Okay, and again blanking at 420 nanometers. Okay, and then we'll take the measurement for absorbance of this total protein reagent at 420 nanometers, about 0.002. Okay, so we'll continue doing this one for 40, 460, 480, 500 nanometers, up to 780, 800 nanometers, right? So, and we'll take the measurements and we'll record them on our paper in here. So now we'll do the blanking for 760 nanometers. Okay, blanking. Okay, measure the absorbance of the reagent, total protein reagent. It's 0.231. We'll go, we'll modify to 780 nanometers wavelength. I went in the other place. So 780 nanometers. We'll blank the instrument. Okay. Okay, we'll measure the absorbance at 780 nanometers. Okay, 0.196. We'll go to 800 nanometers. this is going to be the last measurement for us. So 800 nanometers, blanking the instrument, and then we'll measure the absorbance of the total protein reagent at 800 nanometers. Last measurement. Okay, so 0.161. Now with these values, so the values are here for the whole, wavelength spectrum in here from 400 to 800. We have the absorbance values. So it's a little bit of, inflection in here at 6 and 7, 414, 416 nanometers, where the absorbance of the reagent is less than the water used as reference. Okay, we are going to plot the graph. So we are going to plot in here the graph for the absorption spectrum of total protein reagent equipment performed on Genesys. Okay, 20, sorry, 20. And today is 6/29. So we'll start, with the 400 nanometer. We are going to set up the y-axis as maximum value is 0.337. So 1, 2, 3. This one will be 0.1, 0.2, 0.3. Okay. 0.05, 15, 25, and this one 35. So we start from here 400 nanometers and we go up. The first value 10027. So this is 25, about here. This is the first point, right? And we'll continue with next 420. So 420 will be up here. 420 at 0.002. Oh, it goes down, right? It goes down like that, and we'll keep going, placing the points for all of these, sets of, measurements. So the absorption spectrum looks like this one. Okay, let's do kind of, unifying plotting here. Okay, like this one. So you see that it gets the maximum. The maximum is around between 660 and 680 nanometers here, and then it goes down. So maximum absorption spectrum will be around, so let's say that this is the peak and this is somewhere, it's about the lambda max, right? So lambda max, which is around, let's assume that is 670 nanometers. This is red, right? In red. So this is about 660, 680. Let's say that this is the lambda max, right? So this is the absorption spectrum of total protein reagent performed with an equipment Genesys 20 and today 62920. So once again, this is the absorption spectrum of total protein reagent over a range of wavelengths. So the absorbance findings over the full range of wavelengths constitute the absorption spectrum. This is the absorption spectrum plotted on this piece of paper.